Okay, we're still in 11.2. We have just a couple of things, or really one more example. My video cut off on me. So we had to finish example 7 in 11.2. And on that last video, I had gotten down to, we had S of n equals n over 2, and we had a1 plus an. And we were looking for S of 50, right? And we had already figured out that A1 was 2, so N was 50, A1 is 2, and we had just found out that A50 turned out to be 100. So we're going to use this formula. So we have N over 2, 50 over 2, A1 is 2. AN, that's 100 because that's A50, N is 50. So we get 25 times 1 over 2. Do that in your calculator, 25, 50. So the 50th partial sum is 2,550. And finally, example 8. Example 8. Example 8 says find the sum. Find the sum. And they give me sum I equals 1 to 60. Sum I equals 1 to 60 of 3i plus 5. 3i plus 5, yes. Well, again, I've seen before that I'm going to need to know A1, I'm going to need to know D. So let's write out a few terms for the sequence. So when I is 1, put a 1 where the I is, 3 times 1 plus 5. So this right here is when I is 1. Plus when I is 2, you'll have 3 times 2 plus 5. So that's when I is 2. When I is 3, you'll have 3 times 3 plus 5. So on and so forth, right? And I'm going to go ahead and do the 60th term. When I is 60, you'll have 3 times 60 plus 5. Okay? So 3 plus 5 is 8. 6 plus 5 is 11. 9 plus 5 is 14. Dot, dot, dot. And that 60th term, 3 times 60 is 180 plus 5 is 185. Okay? 185. Now, we knew that 3i plus 5 was linear in the variable I, so this really is y equals, you could think about this function as y equals 3x plus 5. That's a linear function, right? And so we clearly see that as I go from x equals 1 to 2 to 3, all I'm doing is adding a multiple of 3. So again, when x equals 1, which corresponds to when I equals 1, you get 3 times 1 plus 5, 8. When x equals 2, right? When x equals 2, you're just adding 3. 3 times 2 is another 3. 3 times 3 is 9 plus 5, you get 14, right? Or, no, 3 is 2. You get 11, I'm sorry, 11, all right? When x is 3, you add another 3. 3 times 3 is 9 plus 5, that's 14. So we clearly see it's linear, and hence that thing, that D will never change. As I go from 1, I equals 1 to 2, I'll add 3. I equals 2 to 3, I add 3. I equals 3 to 4, I'm gonna add 3. So this is definitely an arithmetic sequence. You have to kind of verify that it's arithmetic, and it is, okay? Well, we clearly see that A1 is 8. We clearly see that common difference to go from one point to the other, 11 minus 8 is 3. And we have A60. A60 turns out to be 185. Okay, 185. So we're using this same formula. We're trying to find S sub 60. So if I use that formula, N over 2, well, N is 60. 2. Okay? And then A1 we just said was 8. Plus A60, 185. Okay? Well, do that in your calculator. S of 60 would be 5790. The 60th partial sum, 5,790. So that's how we do that. All right. There's one more example, but I think it's pretty straightforward. So that concludes section 11.2.